Okay, we're now going to go through example 6, which is an empirical formula example. So this example says a compound is found to contain 72.3% iron and 27.7% oxygen by weight. Calculate the empirical formula. So remember, empirical formula is really important because there's a lot of chemists in the medical and the drug industry. As they discover new drugs, it's really important that they can find the empirical formula to determine the properties of that new drug. So this is an example where we have a metal and a nonmetal. So this is more of if they would discover maybe just a new compound in general. But it's really important that you guys know how to calculate the empirical formula. So in an empirical formula problem, you could be given quite a few things. You could be given the masses right off the bat. You could be given a data table, or like this example, you could be given percents. So it all depends on what you're given, on how you're going to start the problem. In this problem, you're given percents. The best thing to do when you're given percents is to assume that you have 100 grams of the compound. Okay, because if you have 100 grams of the compound, 72.3% is going to be 72.3 grams. So if we assume 100 grams of the compound, we have 72.3 grams of iron, 27.7 grams of oxygen. Now, it actually doesn't matter the exact amounts. What really matters is the ratio. So if you want to say that you have 50 grams and you want to calculate 72.3% of 50, you can do that. But if we assume 100 grams, it makes our life a lot easier. So we assume 100 grams of the compound. Now we have the masses that we need. Now, from there, we have our masses. We need to convert to moles. Okay, so to convert from grams to moles, we use the molar mass that's on the periodic table. So 55.85 grams for iron, 16.00 grams for oxygen. What we get is 1.2945 moles of iron, 1.73125 moles of oxygen. Now notice, I haven't rounded my significant figures yet. I would recommend leaving this unrounded as you work through these empirical formula problems, because the more significant figures you have, the more exact your answer, and then you're going to know if you have to use that 0.05 rule or not. So we have our iron, we have our oxygen. The next thing that we have to do is divide by the smallest number. So if we compare our iron to our oxygen, notice that iron is the smallest. So you have 1.2945 moles of iron. Divide both numbers by the smallest. Okay, because if you do something to one number, you have to do the same thing to the other. So we divide our iron, we get 1. If we divide our oxygen, we get 1.337. Now, we have to kind of think about that. Is that close enough to 1 or to 2 to round? Well, not really. So what we have to think is that 0.337 at the end. Well, think about it. 0.33 is 1/3. So we can actually multiply this oxygen by 3. Okay? However, if we do one thing to the oxygen, we have to do that same thing to the iron. So we multiply the oxygen by 3 and we get 4.01. Okay, very, very close to 4. We then have to multiply our iron by 3. Okay, so we get 3.00 for that. Now, these numbers that we get, those are our subscripts. So we have 3 irons, 4 oxygens. Our formula is Fe3O4. So that is the empirical formula of this problem that you were given.